On longer timescales, and I'm talking here about tens of thousands of years to millions of years, the things that determine the global average surface temperature, there's not actually very many of them. So it's things like the amount and the distribution of the energy that we get from the sun, the properties of the surface of the planet, so that might be the size and position of any ice sheets and the position of continents, and the composition of our atmosphere, which changes slowly due to geological processes that affect the natural carbon cycle. These natural but quite slow variations explain why we've had ice ages in the past and why the planet was very warm in the time of the dinosaurs.
The climate does vary on the timescales of hundreds or thousands or tens of thousands of years, but what makes modern climate change unique is that it's much faster than climate change typically is, and also it's in the direction of getting much, much warmer. Whereas previously we've gone from colder climates of an ice age into warmer periods. Now we're going from a warmer period into a very warm period, and that makes it very different.
What we've come to understand by the term climate change is the variations due to human activity over the last century or two. We refer to that as anthropogenic climate change. The anthropogenic climate change we see is superimposed on the natural variability in the climate system. And so it's perfectly consistent with our understanding of climate change for temperatures to stay stable or even to decrease for a few years. And we think that's what happened during the global warming hiatus in the early 2000s, for example.